Our study compares the El Niño Teleconnections between reanalysis and the UK Met Office climate model. Our research question is, how does model bias in the North Pacific jet affect El Niño teleconnections? At the end, we also explore the origin of this jet bias. El Niño peaks in boreal winter, with strong teleconnection to the North Pacific. Panel A shows the geopotential height anomalies in reanalysis. The circle highlights the Aleutian low. It is strengthened during El Niño by Rossby wave propagation. Panel B shows the El Niño teleconnection again, but this time in the climate model. Panel C shows the difference. The Aleutian low is clearly weaker in the model. As the strength is related to Rossby wave, we investigate the waveguide. Panel D shows the upper-level zonal wind that behaves as a waveguide. The black contour indicates the reanalysis jet. Over the North Pacific, the shading clearly shows a southward shifted model jet. We hypothesize that this obstructs wave propagation from the tropical El Niño region to the North Pacific. This may explain the weaker Aleutian low. To test our hypothesis, we perform wave-making experiments using an idealized biotropic model. The model is prescribed with two different upper-level jets, namely from reanalysis and from the climate model. In panel E, with the reanalysis jet prescribed, El Niño can force the Aleutian low. In panel F, we repeat the experiment, but this time with the southward shifted climate model jet from panel D. Panel G shows the difference. By only changing the jet, the Aleutian low is weakened, similar to panel C. Our experiments support our hypothesis. To conclude, it is important to reduce North Pacific jet bias for better El Niño teleconnections. Finally, we also investigate the origin of the jet bias. In panel H, we take the tropical biases from the climate model and prescribed them in our idealized model. The North Pacific jet is then shifted southward, similar to panel D. Therefore, one way to reduce the jet bias in the climate model is to reduce the tropical biases first. Further details of our work, including the effects on the North Atlantic and Europe, are documented in our Journal of Climate publication at the bottom.